the pointer and we can say.
Great. So, hello everyone. My name is Ranim, and I'm here to present my work that I did together. That is based on my master thesis, and I did together with my supervisors Alexander and Stefan. And the title is Evaluating Endless Calibration for Natural Language Understanding for Dialogue Systems. So I'll start off with the simple scenario of an interaction with a dialogue system to clear up some terminologies that I'll be using. So given the four main components of a dialogue system, the interaction is initiated by a user utterance that is recognized by the automatic speech recognition and then passed to the NLU component. And the NLU component then performs intent classification and returns what we call an intent ranking list. And the intent ranking consists of multiple hypotheses, where each hypothesis consists of a predicted intent and a corresponding confidence estimate. And the hypothesis with the highest confidence estimate is usually on top. Then this output is passed to the dialogue manager that checks its compliance with the dialogue policy, fetches certain information, sends it to the natural language generation unit, and then respond to the user accordingly. And the goal of this study is basically to evaluate the confidence estimation of NLUs. So we wanted to see how reliable the NLUs are. So the first step was basically checking existing evaluations of NLUs. And we saw that NLUs has been previously evaluated for their user interface usability, the availability of certain features, and most commonly the performance, which depends only on the top intent. But taking the performance, so consider the performance of this NLU that outputs a top hypothesis with a 96% confidence, and another NLU in the exact same scenario that outputs the same top intent, but with a lower confidence. So the performance of these two NLUs are exactly the same, because the top intent is the same, regardless of the confidence estimation. So what we had to do is basically checking evaluations and benchmarks of other models. And we saw that for some models, including neural networks, in addition to performance, calibration has also been evaluated. And calibration is basically the extent of which confidence estimates reflect the true likelihood of a prediction. So, for example, if a model predicts a hypothesis with, let's say, 70% confidence, and this hypothesis is 70% likely to occur, then this model is well calibrated. So we adopted this measure. In our study, we evaluate 5 NLUs, mainly IBM's Watson Assistant, Microsoft's LUIS, that are cloud-based, and then open source like Snips and Rasa with 2 pipelines. The first one is based on an Sklearn classifier, and the other is based on a diet classifier. And we train them on a multi-domain data set. More specifically, we take this data set, then we perform repeated random subsampling as a cross-validation method, and on 10 iterations. And we end up with 10 different data sets. Then for each data set, we split into training and test set. We process the training set, pass it to the NLU, and then it would train an NLU model, then use the NLU model to parse the test set. And that would return a set of predictions that would be the input to our evaluation pipeline. After we're done with the evaluation, we perform a statistical analysis just to see if our results are significant. Now let's talk more about our evaluation. So to measure the calibration, we use reliability diagrams that are visualizations of a model's calibration. And we also measure the Spearman's correlation. We calculate the Spearman's correlation between confidence and instance level accuracy. And this is really meant to capture the monotonicity of the NLUs. In other words, we want to see for example, with an increase in the confidence, there will be an increase in the true likelihood or accuracy of the hypothesis. And we extend these two measures to look at all hypotheses in the intent ranking rather than the top one. And we capture that on two different levels. So on a rank level, where we consider hypotheses on a certain rank, and on a model level where we consider the aggregated results of all hypotheses regardless of the rank. We were also interested in seeing if there's any correlation between calibration and performance. So we also measured the performance in terms of accuracy and F1 score. And moving to the results. So this is I'll start with the reliability diagrams on both levels, then the Spearman's correlation on both levels. So starting with the reliability diagram, this is the model level reliability diagram, and it shows the black diagonal line represents a gold standard of a perfectly calibrated model where the confidence estimate equals the true likelihood. And each of these curves represent a different NLU. So looking at the purple curve, we see that Rasa Sklearn shows the best calibration as it is the closest to the gold standard. And then Lewis and Rasa are perhaps not as good as Rasa Sklearn. And then on range, in this range between 0.1 and 0.2, we see a clear miscalibration in Watson. So on a rank level, we create reliability diagrams for ranks 1, 2, 3, and then 4 to 10. And the reason we merged ranks 4 to 10 is because the confidence estimates on these ranks were confined to a very small range, which was kind of sparse. So, but although we merged them, we still observe a clear sign of data sparsity, which makes this diagram hard to interpret and perhaps not very informative. However, if we look at the first three ranks, we see that Rasa Sklearn still shows the best calibration, as it is the closest to the gold standard. And Snips, Watson, and Lewis become worse on low ranks, so they deviate away from the gold standard. While Rasa becomes even better and gets closer to the gold standard. Another thing that we noticed is that the NLUs that used to be underconfident on the first rank become overconfident on lower ranks, and vice versa for Rasa that is overconfident on the first rank and then becomes underconfident on lower ranks. Now we're done with reliability diagrams. So moving to our quantitative results. So the Spearman's correlation results. On a model level, we see that Rasa Sklearn again shows the best calibration, the highest monotonicity with the highest Spearman's correlation. And Snips comes at the end with the lowest Spearman's correlation. So on a rank level, we introduce this diagram and we call the calibration profile. And it basically shows how the monotonicity of the NLUs changes across ranks. And we see that in general, the monotonicity decreases for all NLUs the lower we go in the intent ranking. And more specifically, we see that Rasa Sklearn shows the highest monotonicity on the first three ranks. Then Lewis shows the highest monotonicity on ranks 4 to 7. And on ranks 8 to 10, there wasn't really a significant difference between the NLUs. So after we got all of the results for the calibration, we wanted to see if the reliability diagrams resonate with the Spearman's correlation results on both levels. And we see that on a model level, they actually resonate with each other since, for example, Rasa Sklearn shows the best calibration in the reliability diagram and the highest monotonicity in the Spearman's correlation results. And the miscalibration that we observed in Watson in the reliability diagram was reflected in a low Spearman's correlation. However, on a rank level, we observed some dissonance. So going back to our calibration profile, we saw that the monotonicity decreases for all NLUs the lower we go in the intent ranking. But that is only applicable for Watson, Lewis, and SNPs that get like a lower calibration on lower ranks. But it doesn't reflect Rasa Sklearn and Rasa diet that either remained the same or got better the lower we go in the intent ranking. And we wanted to investigate this more. So we started looking at the confidence estimates distribution on each rank and analyze the measures that we used. So, so these are the distributions of the confidence estimates on each of the ranks. And we saw that the lower we go in the intent ranking, the distribution the range becomes smaller. So that affected the variance of the confidence estimates, and decreased the variance. And one thing that we got to know is that the Spearman's correlation is not only affected by the monotonicity, but also by the variance. So the lower the variance, the lower the Spearman's correlation. So we're done with calibration, moving to the performance. As I mentioned, we used accuracy and F1 score, and we could only record that on a model level since performance only considers the top hypothesis. And our results were pretty consistent. So Watson showed the best performance, and Rasa Sklearn showed the lowest performance. Now that we got both the calibration and performance results, we wanted to see if they are correlated in any sense. And so our first idea was performing a statistical analysis, a statistical test, but we couldn't do that because our sample size is very small, so we only had 5 NLUs. So what we did instead is plotting the results using a scatter plot, and then we attempt to find any patterns or trends, if they exist or not. And they don't. So yeah, we couldn't identify any patterns, and that made us realize that perhaps a well-performing model is not well calibrated, and vice versa. So to wrap up, we saw that there is a possible trade-off between performance and calibration. We also saw that the measures that we used, we adopted from other models and we used for NLUs, are mostly effective for comparisons across NLUs rather than across ranks, because the variance would play some role in that. And we also acknowledge that there may be other factors that could have affected our results. So for example, the choice of classifiers. So all of our classifiers were multi-class classifiers beside Watson, which was a multiple binary classifier. We also disregarded out-of-scope intents since it wasn't provided by all NLUs. And that's it. I'm happy to take some questions.
Thank you. Great talk. Interesting work. The calibration stuff, the reliability. What's your take on if it's overconfident versus underconfident? Because if it's overconfident, then it's getting stuff wrong and it doesn't know it. But if it's underconfident in a dialogue system, it will, maybe you could use confidence to determine, should I ask a clarification request? And if it's underconfident, even if it's correct, a clarification isn't that much extra bother. I'd rather it ask me a clarification to get it right, even if it was right in the first place, than for it to be wrong and not ask a clarification. So the stuff that's overconfident, even if it's a better correlation, seems to be worse than if it's underconfident and it's farther away from that curve. what, have you given that some consideration? What, I don't have a question here. It's more, just because it's highly correlated doesn't, it depends on which side it's correlated on.
Yeah, so that's a great point. I think the main idea, so when we started this, is to kind of understand the nature of the confidence estimation of the NLU. So as you said, like, depending on whether it's underconfident, overconfident, like, you know when to ask a clarification request or not. And we also thought that it would be really helpful. So regardless of whether it's over or underconfident, so the more reliable it is, maybe, so what does reliability mean? Again, so these confidence estimates would make sense, right? So they would reflect the accuracy or the probability of that hypothesis to actually occur. And with that, it would give some potential to, for example, detect ambiguities. So when you have two intents that have like similar probabilities. And I think that would also help clarification requests. So let's say if a model is reliable, but I don't know, perhaps underconfident or something, then it would also help you to know what clarification request to ask. So for example, you would say, do you mean this intent or this intent? That, you know, consider different hypotheses that actually reflect that they are ambiguous or not. Does that make sense?
Yeah, this is like a fundamental question. I'm not sure if you actually showed it in the slide. I might have missed it. But so you're comparing the confidence levels to a ground truth. What is the ground truth that you're comparing it against?
You're asking what does the confidence, so what does it represent, right?
So you're comparing your different frameworks confidence distribution to like a ground truth, right? Or are you just are you comparing it to some kind of a reference confidence distribution?
Yeah.
Where are you getting that from? Is that like I'm trying to understand what the ground truth of the confidence distribution is.
The distribution of the confidence estimate.
Yes.
Where do I get that from?
Yeah, like the original one.
Yeah, so so we have a set of predictions, right?
Yeah.
And in each prediction we have, you know, an intent ranking.
Yes.
So let's say the distribution of the confidence estimates on rank 1, let's say. So we take the top hypothesis, so all of the hypotheses on rank 1, and then we get their confidence estimates, and then we plot them into a bar plot and see what is the range. So for example, usually on the first rank, you have ranges between 1 or 0 until like 0.7 or something. So top hypothesis would most likely be within this range. And then the hypotheses at the end that are not likely to occur, they would have a very low range.
Okay, thanks.
Hi, everyone. So if the model is more well calibrated, does that mean if you were to like re-rank the intents, it would like perform better? Or like also when you measure performance, you looked at the top 1 intent, but what about if you looked at like the top 2 or top 3? If you were to re-rank it, performance improved?
So taking the first question, calibration is, so I'm not sure what you mean by re-ranking them, but it basically means like how reliable the confidence estimates are. So when I say the top hypothesis has a confidence of 0.5, then it's like 50% chance to actually occur.
Okay. Yeah, by re-ranking, I mean if we were to use extra contextual information to be like the top 2 response is the one that I should use instead of the top 1 response. That's it.
So this part is kind of, so yeah, it's one of the main components that we use to measure the calibration, and it's what I call instance level accuracy. So this is where we get to know which one is better. But yes, if we re-rank them and the one that is actually, not better, sorry, the one that is actually the correct intent. So if we yes re-rank it, then yes, it should show a better calibration. And your second question was?
The second question I'll take offline due to time.
Okay.
So thank you.